Let's get back to our example and see what the data look like for a single consumer. We will run a regression with a ranking of the profiles as the dependent variable and dummy variables representing the attributes as the independent variable. The columns have the values of the attribute dummy variables, that is the x's, followed by the profile ranking. Column 1 shows the dummy representing design A, column 2 the dummy for design B, etc. Each row shows one profile. So the first row is profile 1, which has pack design A, brand K2R, price of $1.19, no good housekeeping seal, and no guarantee. Following the guarantee column, you have the profile ranking, which for this profile is 13 out of 18. The last column shows the ranking in reverse order, that is, with 1 indicating the least preferred and 18 the most preferred. This is called reverse coding, which is achieved by flipping the code so a higher number means it is more preferred. This is not necessary, but it makes interpretation of the results easier because we are accustomed to thinking a higher number means more preference. Remember how to run a regression in Excel? If not, you might want to review that lecture before continuing. Once we run the regression, we look at the key results, which are the R-squared, which here is 0.983 or 98.3%. This means the attributes explain 98.3% of the variation in preference, which is really nice. The significance of the F statistic, which indicates whether the R-squared is statistically significant. Here the significance level is well below our cutoff of alpha of 0.05, so the R-squared is indeed significant. The p-values for the coefficients, which are all less than 0.05, indicating that the coefficients are significantly different from 0. And finally, the coefficients, which show the contribution of the attributes to preference. So now let's put these results to use and figure out the utility or value of each profile to the consumer. To do this, we go one profile at a time. We multiply the coefficients for each variable by the value of the variable for that profile and then add up the total for the profile. This gives us a utility value of 6.5 for profile 1, 7.66 for profile 2, etc. Looking down the last column, we can see that profile 4 has the highest utility value among the ones shown here, with a utility of 17.66. This means that it is the most preferred combinations of the ones shown here. Keep in mind that there are other profiles not shown here, and we need to look at all 18 profiles to identify the one with the highest utility. That's the first goal of conjoint analysis. A second goal of conjoint is to identify the attribute levels that are most preferred or desired. The table shows the coefficients or part-worth utilities for each level of each attribute. Keep in mind that they are interpreted relative to the baseline level that was coded with all zeros. For pack design, B had the highest utility of 3.5 units. For brand, Bissell had the highest utility. Even though it was 0, it is still higher than the others which are negative. For price, 119 had the highest utility. A good housekeeping seal added value relative to having no seal, and a guarantee also added value relative to no guarantee. Based on the part-worth utilities, we can also predict which profile will have the highest score. It will be simply the combination with the highest part-worth levels on each attribute. Here the most preferred profile will be Pack Design B with the brand name Bissell, priced at $1.19 with a seal and with a guarantee. This approach works when there are no restrictions on the attribute combinations that you can have. There may be other situations in which the highest value combination of attribute levels is not feasible for technical or other reasons. For example, in a conjoint study on car preferences, you may find that high gas mileage and quick acceleration may be the most preferred levels, but it may not be possible to actually make a car that has both features. So that's a caveat to keep in mind. A third goal of conjoint is to identify which attributes are most important to consumers. Here, rather than directly measuring importance, we use the coefficients or part-worth utilities to infer the importance of attributes. The criterion for importance is the difference between the highest and lowest part-worth utilities for each attribute. The bigger the difference, the more the impact that attribute has on preference. For example, in pack design, the highest part worth is 3.5 and the lowest is minus 4.5. So the spread or difference between them is 8 units, 3.5 to minus 4.5. This is greater than the spread for any other attribute, so we would conclude that pack design has the biggest impact on preference. By going from design A with the lowest part worth to design B with the highest part worth, we can increase preference by 8 units. No other attribute can increase preference by that much, so we conclude that pack design is the most important from the standpoint of impact on preference. The next most important attribute is price with a spread of 7.67 units. The lowest impact is that of the Good Housekeeping seal with a spread of only 1.5 units. That concludes our discussion on conjoint analysis. As you can gather, it has many important uses from a marketing standpoint. It is used to identify attribute importance, preference for each level of each attribute, and the most preferred product profile. It can be used to forecast market share for new products. We can do this by calculating the total utility for the new product given its profile and compare that with the utilities for competing products. Finally, it can be used to segment the market based on the coefficients. By grouping people based on their estimated coefficients, we can identify groups that value certain attributes more or prefer certain profiles more.